Welcome back to the deep dive. Okay, so if you've ever tried to run even one high-res video signal, just say 30 feet across a room, it can be a real headache. Well, today we're taking that complexity and really cranking it up. We're doing a deep dive into massive scale video distribution. We're focusing on the WolfPack Light High Capacity HDMI Matrix Switcher system. And this isn't your standard home theater gear. Nope. This is more like the nerve center for big control rooms, command posts, maybe huge sports bars, places where you need dozens of inputs showing up on dozens of screens. All at once, super reliably, and instantly.
Exactly. And the mission here, it's not just about, slinging video around. It's really about beating the logistics. The big challenge always in large-scale AV is kind of threefold, right? You've got these massive setups, like tons of inputs and outputs. Then they're sending really good quality video over long distances without it degrading. And maybe the sneakiest part, managing power and just the sheer complexity way out there at the screen. And our sources, they confirm these WolfPack Light switchers, they're built for exactly this. We're talking configurations up to 64 HDMI inputs and 64 of those R45 Ethernet outputs. So we kind of need to peek under the hood, right?
Yes.
See what's special, what tech lets them hit that scale, that distance, and do it efficiently. That's the dive.
Okay, let's start with that scale because, wow, 64 by 64, that's huge. When you say 64 sources potentially feeding 64 screens, what kind of place are we picturing? Like Vegas sportsbook walls, security hubs?
Yeah, exactly, those kinds of places. Or maybe large university lecture halls networked together. Think about managing all those video streams live in real time. It's a serious task.
And that scale immediately bumps us into the distance issue, doesn't it?
Right. Your standard HDMI cable, it pretty much gives up after maybe 50 feet, if you're lucky. But here, the spec sheet says distribution over CT6 cable up to 450 feet. 450, that's nearly what, 1.5 football fields?
Wow.
Yeah, and you absolutely need that kind of reach in big venues or buildings with multiple floors.
Okay, I did notice, though, the resolution is pegged at 1080p. In today's world, everyone's talking 4K, even 8K. Why would these big systems stick with 1080p?
Ugh, that's a really sharp observation, and it's key. So yeah, 4K gets all the headlines right, but 1080p, that's the reliable workhorse for this kind of high-density, large-scale stuff. It comes down to stability and bandwidth, basically. Think about it. You're pushing maybe 64 different video streams across hundreds of feet. Sticking to 1080p keeps the bandwidth needs way lower. That means less latency, better compatibility with all sorts of displays, and crucially, rock-solid stability, no dropouts. That's what mission-critical places demand. You choose uptime over, the absolute highest pixel count.
Gotcha. Stability over sizzle. Makes total sense.
Yeah.
Now, back to the cabling for a sec. You mentioned CT6 is recommended. But here's something interesting. The source material, they claim it works flawlessly, even with older Heat 5e cables.
Yeah, flawlessly. That's a strong word, isn't it? Especially in busy commercial environments with lots of electrical noise. But if that's true, wow, that backward compatibility, that's a massive selling point. Think about retrofitting an older office building, maybe one wired 15 years ago, with CAT5e. Avoiding a full rewire could save, potentially hundreds of thousands of dollars. So the tech doing the sending and receiving, it must be incredibly robust to hit that standard on an older cable.
Okay, let's unpack that then. How exactly do they manage that 450-foot distance and keep the picture looking sharp?
Yeah.
That brings us to their own special sauce, right? LHDT.
LHDT, yep. Long HDMI distance technology. It's HDTV Supply's proprietary way of handling that signal extension over standard network cable. Now, we don't have the exact blueprints, obviously, but to maintain quality over that kind of distance, it likely involves some pretty smart stuff. Sophisticated signal compression, maybe, error correction, definitely robust equalization. It's got to be more than just boosting the signal. It's actively managing it.
And the benchmark they're aiming for is, well, pretty ambitious. They claim the picture quality, even way out at 450 feet, looks like you're using just a short, 3-foot HDMI cable, which implies basically zero noticeable loss. That's vital if you're looking at, say, detailed medical scans or financial charts.
Exactly right. So LHDT handles the signal over distance. But the other big headache in these massive installs is power.
Right.
Where do you plug everything in? And that leads us to maybe the real efficiency hero of the system, PoE, power over Ethernet.
PoE, so that centralization of power.
Yeah.
That must change the installation game quite a bit. What's the immediate headache PoE solves in, say, a fold 64x64 setup?
It solves the nightmare of 64 separate power adapters. Just picture that. 64 little receiver boxes sitting behind 64 TVs. Maybe those TVs are mounted way up high or tucked into awkward spots. Normally, every single one would need its own power outlet nearby, plus its own little power brick. Bulky, messy, but with PoE. The power travels right down the same network cable that's carrying the video signal. The main switch sends the right voltage down the line to power the receiver. And the result: no AC adapters needed out there at the screen end, none.
Wow.
It cleans up the install massively, gets rid of cable clutter, and maybe most importantly, it removes 64 potential points of failure. Because those little power bricks, they fail, or they get unplugged by accident.
Oh, yeah. Anyone who's ever had to crawl under a crowded retail counter or deal with a packed server rack knows that tangled mess of power adapters, the heat they generate, the outlets they hog. Getting rid of that at the display end, that's a huge win operationally. Less risk, fewer maintenance calls for sure. Okay, so this is where it gets really interesting for me. Moving beyond just distance and power. Let's talk about the actual switch architecture and the speed. This isn't just one big fixed box, is it? It's modular.
So, correct. It's all about flexibility, adaptability. The systems are built using these 4-port cards, which means, you don't have to buy a giant 32 by 32 switch if you only need, say, 16 inputs and maybe 20 outputs right now. Customers can essentially build their own matrix switcher. You scale it up or down in these neat 4-port chunks. So you're paying for exactly the capacity you need today, but you can easily add more cards later if things grow.
That makes sense. And performance. They mentioned speed metrics.
Yeah, and they're fast, really fast for this kind of gear. They're quoting 80 milliseconds for switching time. That's how long it takes to change which source goes to which screen. And also 80 milliseconds for latency. That's the delay from input to output.
80 milliseconds. Okay, that's less than a tenth of a second. Why is that specific speed so important in like a control room or maybe a trading floor scenario?
Because your whole user experience hangs on it. If you're watching, say, rapidly changing stock tickers or monitoring live security feeds, you need things to happen now. Any noticeable lag when you switch views, any delay, it just throws you off. It creates cognitive friction. So hitting that sub-100 millisecond mark makes the interaction feel totally seamless, totally immediate. And that's critical when people are making fast decisions based on what they're seeing.
Got it. And controlling this whole thing seems flexible too. You've got apps, a web interface, but also like physical buttons on the front.
Yep, comprehensive control options. They cover the bases from modern network control to good old-fashioned front panel access.
Okay, moving beyond just moving signals around. These modular cards, they seem to pack in some extra features too. Features that honestly could cost a lot extra if you bought them separately. Let's talk about that built-in processing.
Absolutely. And this is where you start to see the real value proposition in these higher-end systems, right? So the cards themselves include free video wall processing. That's huge. If you want to set up, say, a 2x2 or a 4x4 video wall, you often need another expensive dedicated box just for that. Here, nope. The matrix itself can handle splitting the image across multiple screens.
Okay, that's a big cost saving right there.
Definitely. And then there's resolution scaling, also on the cards. This solves that classic compatibility headache. Imagine you have some older equipment outputting maybe 720p, but your new displays are all 1080p. The system can actually scale the resolution up or down per output card, making sure every single display gets a signal it understands perfectly.
Nice. And what about audio? That's often tricky.
They've thought about that too. The cards offer separate audio capabilities, so you can, decouple the audio from the video if you need to. Send the sound somewhere else entirely, maybe to a separate PA system.
Okay. And there was one more specialty card mentioned.
Yeah, the quad view card. That's another really useful one, especially for monitoring stations. It lets you take one physical TV screen and display 4 different inputs on it at the same time. Quarter screen views. Maximizes your screen real estate without needing 4 separate monitors. So you combine all that video, wall scaling, audio breakout, quad view. It means an installer can potentially use this one core system to handle almost any display need in the building.
It sounds incredibly versatile.
It is. But, okay, let's ground this a bit in commercial reality for you listening. This is serious enterprise-level stuff. While the base chassis, that build-your-own starting point, might be around $600, the price climbs quickly once you start adding those 4-port input and output cards.
So those cards are where the capability and the cost lies.
Exactly, and we can see that in the examples given. A 1080p setup with 16 inputs and 52 outputs, that's listed at $14,200. Jump up to a bigger configuration, maybe 24 inputs and 64 outputs. Now you're looking at around $16,250, and a 32 by 64. That's $16,650. So yeah, you're paying for more than just hardware. You're paying for that guaranteed performance, or reliability over extreme distances, that special LHDT engineering, the PoE system, all of it.
And the company behind it, HDTV Supply. They mentioned being around for 24 years, global reach, and crucially, they're an HDBaseT.org approved adopter. What does that HDBaseT part tell us, especially since their LHDT tech is proprietary?
That's a really important piece of context. Being an HD base approved adopter, it basically signals that the company meets a core recognized industry standard for sending audio-video signals over Ethernet cables. So even though there's specific long-distance tech, LHDT is their own secret sauce, the HD base affiliation provides a kind of baseline assurance. It tells professional installers that the underlying infrastructure, the manufacturing processes, they likely adhere to well-understood benchmarks for performance and maybe even some level of interoperability. It adds credibility.
Okay, so it's like they have their unique approach, but it's built on a foundation that the industry generally trusts.
Precisely. It helps build confidence that you're not buying into something completely, out there on its own.
Right. So let's try and wrap this up. What's the big picture here? When we put together the huge scale, the proprietary distance tech, the power efficiency, what does it all mean? It seems the WolfPack Lite system is a really focused solution for, well, incredibly complex AV setups. We've hit the key points, that massive 64 by 64 potential, the crazy 450-foot reach thanks to LHDT, and, maybe underrated, the huge operational win from using POD to simplify things at the screen.
Yeah, it really shows they've thought through the logistical nightmare these big installs can become. They're offering centralization, central control, maybe more critically, central power distribution. But yeah. Here's the final thought I'd leave you with, something to mull over. When you implement PoE like this and you get rid of potentially 64 individual power supplies out in the field, where does all that power draw go? It all shifts back to the main matrix switch, right, in the rack room. That means that central switch needs some serious, robust electrical circuits feeding it. And the building's overall electrical planning now has to account for the power needed by potentially 64 displays, but all drawn from one central point. So this kind of power consolidation, it fundamentally shifts the risk profile. How does relying on one big, powerful switch, which is also your power distributor, impact long-term maintenance costs? What about disaster recovery planning for the venue? Is it better or worse than a system where maybe only one screen goes down if a local power supply fails? That's a really complex calculation involving budget, safety, uptime requirements, and it goes way beyond just the sticker price of the switcher itself, something